Hi, Justin. Welcome to the Future Proof Operations podcast.
Hi, Benjamin. How are you?
I'm fine, thank you. Great to have you on the show. Today, we will talk about AI and machine learning, and we try to put it into the context of manufacturing. And this will be a very special episode because we will have two episodes. In the first one, we will talk more about the technical background and we try to understand AI and machine learning models even better. And in the second episode, we will take a look into real life examples and projects that you are bringing with you. So, as an introduction from your side, Justin, could you give me a 60 seconds overview of who you are and what you are doing?
Yeah, absolutely. So, my name is Justin Hodges, and I work for Siemens, as does 500,000 other people. Specifically within Siemens, I work in the Digital Industries Software business unit, and specifically at SimCenter, which is a portfolio of software that engineers would use for their physics-based simulation, for their engineering work and their design work, as well as their testing solutions, so things concerning physical measurement. So where I fit in that is I have a technical role for AIML within our product management team. We do strategy, interfacing with customers, technical like marketing asset like publications and thought leadership and things like that. And we work closely with development and with our customers to make sure that what we bring to market in this area of simulation and test solutions is impactful, relevant, and what they're looking for.
Justin, you are passionate about AI and machine learning. Could you share how you came to that passion? So, how did that start?
Yes. I am very passionate about it. So I went to school in a turbomachinery based lab doing aero mechanical hybrid called thermal fluids, thermodynamics, uh, fluid mechanics, turbulence, numerical, experimental, things like that. And in 2017, I took an internship in Princeton on the intersection of CFD and machine learning. In that case, it was for a healthcare application, but nevertheless, it was concerning generating data for simulations via simulations, and then patient information and imaging that were also included as the sources of data for the machine learning models. And I remember distinctly, even though that was in 2017, all my other friends that worked there, when we would get coffee or play ping pong, I'd be like, "So what are you doing today?" And they would say, "Oh, I just regular day replacing all of our simulation models with machine learning." So that caught my attention. And ever since, I've realized that my vector for career would definitely be at the union of something machine learning rated as first priority. And that hopefully also it involved physics and things like that, that, I spent a bit of time in my PhD on thermal fluids. And I really like it for a lot of reasons. But, I really enjoy I would say part of the things I enjoy the most is demystifying, making it more relatable to the skills that we've generated, in school for mechanical engineers. And I love physics, so I also really have a passion for it in order to like unearth new things about why behavior is the way that it is and mechanisms are the way that they are. That's part of one of the reasons I really like it and sort of where it came from.
Mhm. Justin, you said you want to demystify AI or machine learning to start on a very, very high level, but on a or with a simple question at the beginning. But I think for a lot of listeners, it's still very relevant. When you talk about AI and machine learning, could you explain in a nutshell what the difference is or why they are very closely coupled?
Sure. So, and I really like a follow-up to that question, so I'll pay more attention to that one, but to to
Okay.
to sort of sort the house cleaning first,
Yeah.
artificial intelligence is the parent category, and then a sub one to that is machine learning, and then a sub one to that would be things like deep learning. And even most of the things that we'll talk about or that I concern myself with at SimCenter is indeed machine learning. Um, but what I really like to delineate there and demystify is, everyone in school will do linear regression or polynomial regression. So can I be bold and ask you what you say the difference between polynomial regression and machine learning is? And don't feel bad because it's very tricky and simple, and everyone struggles, but I like to ask that one first.
It's a very tough question. I would say both is about finding correlations and working with likelihoods of something. Is that right?
Totally right. And in fact, I would say the definition is more about if it's politically correct versus technically correct, because you're right on, obviously, on the technical, but that's part of the
Mhm.
thing is what is and what isn't machine learning. And a couple years ago, a very famous group of machine learning called Kaggle released a yearly survey. And part of their survey was what are the most used machine learning models in the industry? And number one was linear regression.
Yeah.
And so I think that really this is a huge category where a lot of stuff is lumped in and the boundaries aren't super clear. Um, but in this case, I like to think of them in the same family because, in essence, if you have linear regression, for example, the form is fixed. You may do some things to fit the correlations and tune the correlation values, but the form is fixed, right? And in this case, machine learning is more about algorithms that are optimization to find the right values of these coefficients. But now the form can also change substantially, right? If I have a single layered neural network or many layered neural network or transformer model, I mean, there are many degrees of freedom, if you want to call it that, on what can be manipulated to fit the correlation exactly like you said and make it an accurate correlation. And so in this case, I think a lot of people on the demystifying side look at it as something totally different, but it's different technology, but I'd say it's all in this family of regression or classification of statistical modeling. And that's really to me what machine learning is. And I would
Yeah.
differentiate that to artificial intelligence by making it more about like logic and things like that to sort of assign what happens. Whereas machine learning is really about these algorithms that seek to learn from data to minimize error or loss or whatever you want to call it, to find the ideal form, ideal coefficients, weights and biases, whatever you want to call it, such that it can be a mechanism to say, this is the relationship between the data coming in and the thing you're trying to predict. And as far as engineers are concerned that use our software or want to use machine learning in their computer aided engineering, that's the purpose. It's secondary how it works, I think, for a lot of people.
Mhm. The episode starts great. I already learned a lot. Just so let's continue to demystify what you are actually doing as an expert of AI and machine learning. So, how is your usual working day looking like? What you are doing when you are working on AI and machine learning?
Good question. So it is a product management team that I work in as far as this technical role goes. So I would say the normal things apply for any PM role of taking in customer needs and requirements and looking at the business and market opportunities for fulfilling the different ones in some sort of prioritization effort. So product management 101. And then my role specifically is on the technical underpinnings to being successful and implementing those features or products. And in doing so, that is communication and work with the developer team to make sure that that is executed and that we deliver. So that would be, I would say, some sort of summary as far as the strategy setting component of the role goes. But also, part of it is a technical backing and sales engagements role go. So in case there's a big customer need on something where technical expertise is needed to weigh in, then that is where things can get escalated from our Salesforce engineers and application engineers to bring me in and work with the customer on that. And then I would say, we do try to spend some amount of our time doing publications and things like that and talking at conferences based on our focus areas because we're trying to remain relevant in what we're working on. And then we do
Mhm.
spend a bit of time sharing them as far as in conferences and things like that. So it's a mixture of the three, probably the most on the former first one regarding product and strategy.
Okay, so now we have the high level picture, and now I would like to go one level deeper, and I would like to understand how your AI and machine learning technology, how your models are actually working at your customers. We already had a prep call, and of course, I asked you questions about manufacturing companies. So, what are manufacturing companies doing with your models? And then you said there might be even other industries who are working with your products. So, I'm curious what that are or who that are. But If we are going now into manufacturing space, in a factory, for example, and I would ask you, so who is actually working with your models, with your technology? What would you answer?
There's, I would say, two personas, but probably the bigger one is the designer. So in the case of uh, in this case, it would be, someone's probably working with different engineering software to simulate, whatever the component is that they're producing or trying to design, to fabricate and manufacture. And then, of course, the engineers related to the hands-on actual operating of equipment and things like that. And it's really meant to more and more touch both and bridge the gap in between of them. Because obviously, the person doing the design work, maybe they have this nice big HPC and desktop, and they have all the data available to them, so they can afford the time to run these simulations to carefully and decidedly answer questions that they need to design their equipment. But of course, the persona is much different if you're on an operating floor or you're making decisions in real time for the operation and service of your equipment while it's working. You may not have access or the ability to high quality dense information like simulations. You may not have time to run these simulations. And so in that
Mhm,
case, you're talking about more of deployed software that they can connect to and get information from rapidly. And of course, that's a good use case for digital twins and machine learning. So I would say those are the two major personas. And while Siemens works in, I would say, all major industries, aerospace, marine, automotive, etc. In this case, we can sort of distill down the scope to a more narrow view, like you said, in manufacturing or maybe process industries, people manufacturing different
mhm.
chemicals and working with raw materials. And that sort of persona, it's also related to operation of equipment and shop floors and things, among other industries. But I would say those are two that stand out. Maybe operations of heavy equipment and that sort of things, like heavy machinery operating in facilities. So I would say our software is meant to touch both. But we do, I would say, probably have the lion's share being people that are trying to design their equipment or factories or processes, and they have the luxury of, time and resource on the machine that they use.
Mhm. If we stick with the designer persona and the operator persona, help me to understand a little bit better how their roles are changing when they get in touch with AI technology or machine learning technology.
Sure. So let's say we have a mixing vessel that's mixing some fluid. That is a piece of fairly heavy equipment. So there's probably somebody who is a master in fluid mechanics and thermodynamics and mechanical forces and things like that. And they would be
Mhm,
using products to design that to make sure that it would have a nice fatigue life and it would not break, and to ensure that, whatever level of mixing needs to happen is accomplished. Maybe the facility is actually, maybe they're selling their mixing equipment to different power plants or different shops. So they need to kind of operate for all kinds of different chemicals that they could be wanting to mix. Could be a pharmaceutical company making mixing, could be hygiene pump, or actually food industry. So they're making these design decisions based off of probably mostly simulations. And then, of course, a component of physical tests to sort of underpin and back their simulation results. So in that case, that persona is using machine learning probably to make their simulations faster, maybe also leverage historical data so they can make these machine learning models that would learn their design space from their past data. And then instead of maybe day long simulations that are expensive for thousands and thousands of permutations on how the equipment could be designed or operated, they could probably predict a lot of that space with machine learning models that they've created. So they take this time to generate the data, and then they leverage it by making machine learning models, and then they use it and put it to work to save them time by predicting what happens if they, you know, filter different viscosity fluids from day to day, so that when they sell their mixing vessel, they can be sure to whoever buys it that it will perform well. And now to bridge to the operator, this person may for whatever reason, have a demand change and need to change the RPM of the device or something like this. Or maybe they just want to do a health check and they want to check the torque loading on the spinning components inside the vessel. So in that case, they may have discrete, measurements where they can measure it from individual sensors, how the devices are performing. But you can think about, all the information available to that person versus the one doing the simulation with this fully 3D model that has all the information there that they can look at and analyze. There's quite a discrepancy, right? Perhaps the device is spinning at the same RPM, so it may look healthy, but in reality, some of it is breaking off or about to break off, right? So they would want to use machine learning for anomaly detection and fault detection, and these sort of machine learning models that can understand healthy behavior of their measurements versus unhealthy behavior, and then flag the operator to tell them, hey, perhaps you should do an equipment check because the signals of taking data don't look normal, right? Maybe you don't have critical failure, but it seems being some threshold of risk. And then what would be great is the more knowledge the designer could distill into machine learning models to the person working on the, operating the equipment, the better. Because the reality is that, 20 or 30 point measurements inside this device is not the same amount of fully 3D intrusive measurements without actually being physically intrusive, just digitally seeing the results. And so, I'd say a bridge between them are things like dashboards and cloud-based deployed, software or models to share information. I think that's becoming increasingly popular in the space, and that is some of their uh, main points of touching machine learning, I guess. Yeah, and then
Mhm.
and ChatGPT.
So and ChatGPT. So in a nutshell, I heard a lot of important points now, but in the conclusion, it could be there are better decisions. So AI will help to make better decisions. It will help to make decisions faster. When we take a look on the production efficiency, it might help to increase the operational efficiency. And you talked about quality as well. So it might help to keep or improve the quality level of the production line.
Yeah, quality assurance. That's a really good term to describe what machine learning could do
Mhm,
to benefit the person operating the equipment. On the shop floor, I would say quality assurance, and I would say time savings, big time savings. And then
mhm,
even just logistical things, like you see all kinds of vendors and startups at conferences on this topic that will talk about um, using large language models to communicate all the information from one shift to the next, right? If you think about an old school way of someone working on the floor and recording their observations by hand in a book or a journal or something, I mean, that's very ineffective as a means to transfer the information to the next shift. And in this case, I mean, ChatGPT is really effective at increasing our input output capability through things. And in this case, conversationally, recording or asking or searching, like document search, this is just a much better, more suitable way to access this information, especially if, your hands are free, are busy and you're not at a computer and you may be walking around to check different devices and measurement stations. So yeah,
mhm.
I think there's really a lot of themes. These are just a few of them, especially for the designer.
You talked about the designer and the operator, and we talked about how they will interact with AI and machine learning. And I think it's very obvious that they will their role will change. So in future, they might do different things because AI or machine learning will help them on specific other things. If we widen our view right now and not take a look just only on manufacturing, but probably on other industries as well, do you see challenges with the rise of AI technology? Um, when you take in consideration that the people which will interact with that technology might need to change their roles. Even their teams in which they are working currently might not be the teams where they will be in future. So there is a big shift. And do you see a challenge behind that?
So, am I correct to understand your question as related to changing in the workforce and that sort of thing?
Justin, when you talk about the role of operator and the role of designer, and you talk about the collaboration and the interaction with the new technology, with AI and machine learning, I find it very obvious that the role of this personas, so the role of the designer and the operator, might change while the technology is progressing. Do you see a challenge behind that when AI and machine learning will progress in future even more and probably faster, that these roles need to adapt as well? Probably not just in manufacturing, that might be a challenge for other industries as well.
Yeah. Yeah, absolutely. There's a few conversations I've had with people with phrases that stuck. I think one is AI won't replace you, just someone using AI will. So I think there is needed to be a flexibility if you talk about all the different tools and the tool belt of either person in any industry. I mean, it's obvious this is a clear tool for technical people, for hands-on people. I mean, of all kinds of demographics, I think it's very clear this will be something embraced. Um, the analogy there I like is, when tractors came out, farmers didn't go out of business. They just all had to buy tractors. And I think that's
Mhm.
very much the same thing, um, whether it's augmented reality sort of headsets that people have to use so they can do their hands-on work operating on something and then see additional information available to them, or capture their video in a stream-like way to analyze later, or whether it's computer vision to tell them different things. I mean, if you're open to that sort of changes, then I think I think that will definitely be in place. And I was talking to our VP of industry for our business unit a couple weeks ago, and we talked about like how AI will change. And I think it's kind of similar though. I mean, he was pretty senior guys, and he'd been in aerospace for 30 years. So he said it was kind of the same thing when simulation came out, and when it was started to be heavily used. And in his career, they went from being able to consider like maybe 10 simulation designs at once, and then now it's uncommon to only do 10 in one study in one project, right? There may be thousands of designs considered. And so I think there's just always the element of human adaptation to new technologies. And in that regard, AI is not special. Um, but yeah, I think the first thing I gave pretty much answered the question, right? Someone
Mhm.
with
Yes.
AI will or could replace you, not AI itself. But thankfully, I think everyone can see that there's this cross pollination. There's very much mainstream tech creating these new approaches and technologies, and then within a couple of years, they're washing to other people and other industries and other applications so that they can benefit without being principal experts on the subject.
Mhm. Justin, right now, it's very obvious that there's a big hype behind AI. We already had a AI winter, I think 30 years ago, but right now there's a lot of progress, a lot of acceleration behind the whole topic. If you think about the future, how will AI and machine learning models will evolve in the future?
Yeah. So I think the near term, which could still be several years, will be very simple applications in terms of the machine learning technology, right? If you think about, like, for example, what Meta and other companies in Mang did, a lot of it was data infrastructure and IT infrastructure, right? You know,
Mhm.
that much data available in a distributed way really enables things to grow out of it. And in the case of manufacturing, um, the example would be that if someone's manufacturing and doing different processes to produce raw materials, eventually someone will buy the materials and then make something out of them. And that thing, like a car body, whatever, would perform for a certain amount of time. And until eventually it had some sort of failure. If you can capture the entire data from start to finish of how that performed based on decisions made by the person producing the raw materials, like how they did any sort of annealing process and what sort of conditions they did the annealing under and what choices they made and how they produced it, being able to tie that to data years later on how it performed and could have shortened or extended the life entirely till it was done. I mean, that's a lot of key information. And I think that um, that is something recently that companies are doing in manufacturing space, for example, but maybe not all companies, right? So even that, right? That had nothing to do with machine learning, but that is really the foreground for the data. And I think we're still seeing things percolate and mature in terms of availability and also applications adopting AI. So in this case, I think more adoption in other industries, more commitment. is going to be just continuously happening. I've seen that especially since maybe 2020 for my area, like fluid mechanics and mechanical simulation and computer aided engineering. But like you said, I mean, how long did that take? Because that simulation has been a, a thing since the 90s. And Jan LeCun made computer vision models in the 80s, right? And like you said, every 10 years, there's sort of been like a hype cycle where AI would come up and then die. And so I think to answer in short, mass adoption of relatively simple techniques across the entire market will continue to happen for a couple years until it's completely solidified and all the companies are really invested. And then I would say there will be still a couple years further where perhaps not even the most advanced models are out. I think transformers are a good example.
Mhm.
Obviously, innovations happened in transformers for mainstream tech. But if you look at other applications in industries, such as manufacturing or CAE, applications that use machine learning are probably still pretty happy uh, with precursors to transformers. So I think that there'll still be more adoption as far as methods development specific to their industries. I could talk to you at length about what people are doing in the simulation community. And
Mhm.
like I said, only in the last couple of years have people really committed to investing, gathering the data,
Yeah.
and then now just starting to make really like computer aided engineering specific machine learning models. It took a long time just to break away from, the neural networks, the graph neural networks, the very vanilla neural networks and tree-based methods like random forests and XGBoost. I mean, these are very much like as is models. And there was a definite time
Mhm.
period where people were just applying them to their fullest. And then I think the cycle is after that, then more people enter in the research area to improve the models themselves, like fundamentally for the application. And so I think that that's just really started in the last year or so for my industry, my market. And I think in
Mhm.
manufacturing, it's probably the same.
Justin, unfortunately, we are coming already to the end of the podcast, and I would like to ask you a final question, and this could be a segue into our second episode. You already mentioned that you are building solutions for different use cases. Some of them are in manufacturing, some of them are in other industries. If you are thinking about the current implementations, the current solutions which we are building with AI and machine learning, what are the most promising right now where you say, okay, there's a great product market or product solution fit currently? Because I assume there might be some use cases which work better with AI and some of them probably need some more years to go.
Ooh, that's a hard question. So I'll take it start to finish and I'll get as close to a couple applications as possible. So about a year and a half ago, we started laying the landscape of what are all of our use cases and making roadmaps. And there was over 50 use cases at that time.
Mhm.
So quite a lot. But I would say the biggest themes for how machine learning can help in terms of this digital twin group and computer aided engineering niche industry that we're all in, even though it's huge for us, it's still pretty niche in comparison to tech. Um, I would say it has to be, first of all, about time savings with surrogates to simulation. So in the case of manufacturing, there's plant simulations that do scenario planning and logistics. And, anytime anything input wise changes, the simulations have to be redone. So as you know, that's just an incomprehensibly large amount of simulations in terms of what is possible. So I think one area that's most important is probably time savings via surrogates to simulation. And plenty of
Mhm.
those surrogates will be machine learning based. And I think that is one of the biggest areas um, that we'll see machine learning really succeeding in and being adopted in. Because I think also manufacturing timescales are shortening, right? A few years ago, uh, electric vehicles were just kind of starting, and all the major combustion engine companies were just kicking off these initiatives for their first EV. And now they're just trying to produce generation after generation very rapidly in parallel to their legacy combustion engines. So I think the bottom line is these time savings are only possible with big Hail Marys with things like machine learning. 20%, 30% improvements in time won't be sufficient. So that's one. And then although it also supports time savings, I think it will be something related to user experiences and interaction with software. And I think that will largely tie back to large language models. Because if you think about, how long it takes to perform design projects, yes, you care about the accuracy of the answer. And yes, it'd be great if surrogates could predict from historical information new things for you. But when you do use the software, it's not a trivial amount of time. And I think things like ChatGPT have really proven that you can be more efficient and more effective. And so I think it will be, really all about user augmented experiences, conversationally, uh, interacting with products so that it can do really mundane things for you. So you can really focus on what you want to do, because clearly we humans have so many ambitions on what we want to make and create faster, faster, faster constantly. So I would say that's a really key area. And machine learning is one of the only sort of solutions, right? Or technologies for
Awesome.
that solution.
And there's so much more space to discover. Great. That was a great episode. Thanks a lot, Justin. I learned a lot. It's super inspiring to talk with you about the technology. And I'm already looking forward to dive into our second episode and talk about concrete implementations, projects, and your learnings out of them. Thanks a lot for being on the show.
It was a pleasure. Thanks for the conversation. Looking forward to the next episode.
Bye.
Bye.